Hello! Today we're talking about optimizing Solana programs. Solana is built for speed, but if you're not careful, your program might be the slowest thing on it. In this video, we're going on a journey from the comfort of Anchor to the bleeding edge of zero-copy Rust, all the way to the wild west of unsafe syscalls. And just a quick heads up, all compute unit numbers in this video are ballpark figures, based on simple logic like account init and value updates. Real-world performance depends heavily on your program's complexity, data size, and external instructions, so varies a lot. For more ways of programs optimization, check out the best practices list and let's dive in. Solana optimization isn't one size fits all. Think of it like a spectrum from easy-to-use frameworks to low-level control. At one end, we have Anchor, great for teams, audits, and fast dev cycles. At the other, Unsafe Rust, where you squeeze out every last CU, but every line is a potential food gun. And in between, we've got options like zero-copy, manual account handling, and Pinocchio, each offering different trade-offs. Anchor is fantastic for productivity. You get account validation, serialization, PDA generation, and ideal support out of the box. But here's the catch. All that convenience comes at cost compute units. Anchor programs can use upwards of 5,000 CU just to initialize a basic account. Why? Because it relies on Borscht for serialization and auto-validates accounts, even when you don't need it. So how do we fix that without giving up Anchor? That brings us to the easiest way to level up your Anchor programs is to switch to zero-copy accounts. With zero-copy constraint and account loader, Anchor skips Borscht deserialization and accesses account data directly through pointers. It's especially useful when dealing with large accounts or frequent access like order books or AMM states. Using this tip, CU for initialize dropped by around 70 units. Update CU dropped by around 40, which is a small gain but nearly free. If you're ready to say goodbye to Anchor, native Rust gives you a big performance bump. Instead of relying on Anchor's account macros, you use next account info and pass your own instruction data. This means no Borscht, no account validation, and you only pay for what you use. Switching from Anchor to native Rust drops CU usage to around 4,200 for initialize, a solid 800 CU saved. For basic instructions, you can drop below 1,000 CU easily. The trade-off? You lose Anchor's safety nets. But if you're okay writing your own checks, native Rust is a huge win. This is ideal for high-throughput DeFi programs or when CU budgets are tight, like in bundled transactions or auctions. Now we're getting serious. Pinocchio is a zero-dependency framework that replaces Solana program. It's no STD, no alloc, and zero-copy by default. Imagine if Rust was distilled down to its absolute minimum for Solana. That's Pinocchio. It gives you macros like lazy program entry point and no allocator to avoid heap usage and panics. Its account info is just a raw pointer, no structs overhead. Everything is pointer math and slices. It's also the only framework where the word minimalism isn't just marketing. You get control over serialization, instruction routing, and even panic handlers. It's great when you need more performance than native Rust gives you, but you still want some structure like macros and logical entry points. CU savings? Real-world Pinocchio program land between 3,800 and 4,100 CU without touching unsafe. And this is the final boss of Solana optimization. No anchor, no framework, no STD, no heap. You directly invoke syscalls, do pointer math, and write your own instruction decoder. Even panics are avoided with custom handlers. It's risky, but you can hit CU usage as low as 600 and shrink binary size to under 1 kilobyte. But let's be real. You lose readability, testability, and maintainability. And unless you're an expert in low-level Rust, this is dangerous territory. In the real world, actual usage will vary based on logic complexity, number of accounts, external CIs, serialization formats, etc. And only benchmarking your own programs will get you accurate numbers. So, keep your compute lean and your logic clean. Thanks for watching. Bye!